Why did op-amps shrink from bulky tubes to ICS? Imagine a time when electronic devices were giant and fragile, filled with glass tubes that glowed and heated up. That was the world of early operational amplifiers. These first op-amps used vacuum tubes, which were large, delicate, and needed high voltages to work. They took up a lot of space and consumed a lot of power, making them hard to use in everyday electronics. Back in the 1940s and early 1950s, engineers built these tube-based op-amps with twin triode vacuum tubes, which are like tiny glass chambers with electrodes inside. These tubes needed heaters and high voltages, which made the whole setup bulky and fragile. They also used a lot of power, which wasn't ideal for portable or compact devices. Plus, they weren't very reliable because glass tubes could break easily and had limited lifespans. Then, in the early 1960s, things started to change. Advances in semiconductor technology allowed engineers to create integrated circuits, or ICS. These are tiny chips that can hold thousands of transistors, resistors, and capacitors all on one piece of silicon. The first IC operational amplifier, called the Micro A709, was a big step forward. It combined all the parts needed for an op-amp onto a small chip, drastically reducing its size and power needs. The main reason for this change was that ICS could fit thousands of components on a tiny silicon wafer, which meant the op-amp shrank from inches to just a few millimeters. They also used much less power because transistors operate at lower voltages than vacuum tubes. This made IC op-amps more efficient, more reliable, and cheaper to produce in large quantities. Manufacturing ICS also meant consistent quality, unlike assembling individual tubes and discrete parts by hand. The performance of IC op-amps improved too, with better bandwidth, gain stability, and lower noise. These improvements made them perfect for use in modern electronics, from signal processing to embedded systems. The differential input stage in IC op-amps, which allows for both inverting and non-inverting inputs, became a standard feature. This made them more versatile and easier to use in different circuits. Thanks to these advances, op-amps became smaller, more reliable, and more affordable, opening the door for countless applications in electronics and embedded systems. So, the shift from bulky vacuum tubes to tiny integrated circuits was driven by the need for smaller, more efficient, and more reliable components. This change transformed the way we use and think about operational amplifiers in modern electronics.